Today's topic is the system of nonlinear equations in two variables. We use a system of equations, that means more than one equation, right? And we learned how to solve the system of the linear equations, and that involving two or three variables. And now we're going to do nonlinear equations. What are the nonlinear equations? There are a lot. We only deal with the two variables. Only deal with the two variables for today. And then this is the keyword, nonlinear. There are so many nonlinear equations. If you have a y equals mx plus b, that's a very typical linear equation. Anything other than that, if you have like x squared, if you have a y squared, if you have x or y in the denominator, if you have square root of x plus 5, things like that, those are all nonlinear equations. And today we're going to try to use substitution method and elimination method to solve some of the nonlinear system equations. Nonlinear system of nonlinear equations. Okay, now let's look at the first one. We have x squared minus 2y equals 10, and we have 3x minus y equals 9. This is a linear equation, but the first one is not. First one has a square term, it's not. So when you look at this, do you know how to solve it? Actually, if you see, you can have y here is just a single y, and here's a single y. It doesn't have the square term. And here's x, and here's x squared. However, if I can eliminate y, if I multiply the bottom equation by -2, I'm going to have positive 2y, and then I can add to it. I will just get rid of the y. So that's one way to do it using the elimination method. Or do you remember when you want to use the substitution method, you want to have one variable has the coefficient of 1. Actually, -1 is also good. So let me try both methods and to see. I want to show you that use either method that will work, okay? So first of all, I'm going to use the substitution method. So I'm doing, this is 1, this is 2. All right, so what I do is for the number 2, if I move y to the right, it becomes a positive y, and I bring 9 to the left, I will have y equals 3x minus 9. Okay, so what I'm doing is I add a y on both sides, and I subtract a 9 on both sides, and I switch the left and the right side. So I get a y equals 3x minus 9. And then, because this is a substitution method, so I'm going to substitute this into another equation, so y. All right, so that will be x squared minus 2y, and that y, instead of y, I put 3x minus 9, and equals 10, I bring the 10 over. It becomes this. All right, now I can simplify this a little bit. That becomes x squared minus 6x plus 18 minus 10 equals 0. All right, and then that is x squared, combine like terms, 18 minus 10, which is a plus 8, equals 0. Then you can factor. You either use the factor method to get x minus 2 and x minus 4, because here the coefficient is 1, so you're looking for two numbers. They add up to -6. The multiplication or the product of them is a positive 8, so that's minus 2 minus 4 equals 0. So do you get the answer? Yeah, pretty much, right? So you get x equals 2 or x equals 4. Okay, and once you know x, then you just need to substitute those x into here to get a y. And then when x equals 2, 3 times 2 it's a 6. 6 minus 9 is -3. So I will have a y equals -3. All right, and then when x equals 4, 3 times 4 is 12 minus 9. Okay, so I get a positive 3. So those are the two solutions to this system of nonlinear equation. All right, now how about using the elimination method? Just like I said, I use number 2 equation if I multiply this by -2, then the coefficient of this y will become +2, so later I can add to it. So let me just copy the first one, x squared minus 2y equals 10, and the second one, if I multiply this by -2, I get a -6x plus 2y equals -18. Then I can add up, eliminate y, so I get x squared minus 6x equals -8. All right, and then you bring this 8 over, or you plus 8 on both sides, so you get x squared minus 6x plus 8 equals 0, and then the rest will be the same. You see, this one is exactly the same as this one, right? So next one, you can just factor it, and then to get the solution of x, and then you can bring x to either equation to get a y. So you get a pair solution. So you get the two solutions. There's another way to write your solution is this. It's a 2, -3. The other one is a 4, 3. All right. So there are two solutions here. And this one, x squared minus 2y equals 10. If you move 2y over, then divide it by 2 on both sides, you get a quadratic equation. So you're going to get, the first one is, I don't know where is that, but I just draw. This is the first one, this is quadratic. And the second one, you move the y over, so you actually have like something like this. Okay, whatever, it was very similar, it's just a line. So what it says, when you have this two solution, that is the 2 points that on both curve or both graphs. That's the general idea about that. And of course, you don't want to use the graphing method, right? Because I don't want to use it. All right, so that is the first example, and let me give you another example. 4x squared plus y squared equals 13, and then x squared plus y squared equals 10. Oh my, there's no first degree term. It has all the squares. I have x squared, I have a y squared. So what are you going to do? Well, you can just treat this x squared and a y squared as the whole piece. Okay, now we have, here is a y squared, here is a y squared. If we multiply the second equation, this is the first, this is the second. If I multiply the second equation by -1, I will have a -x squared, -y squared equals -10. And then I can just simply add to my first equation, and that will eliminate y squared, right? So I do that, so I get a 3x squared, and then no y squared anymore. 13 minus 10 is a 3. Okay, so 3x squared equals 3. I divided by 3 on both sides. I get x squared equals 1. Therefore, x equals 1 or -1, isn't it? So once you have x is 1 or -1, which means your x squared is 1. So what is your y squared? If you look at here, your y squared should be 9, because 1 plus 9 is 10. And then y should be plus 3 or -3, which means you have 2 possible x and 2 possible y, and they're not even coming in pairs. It's not like x equals 1, you can only have +3 as your y. No, it can be both. Therefore, there are a total of 4 solutions. So the solutions are 1, 3, -1, 3, 1, -3, and a -1, 3. So those are your solutions to this system of equations. Because for all the 4 points, their x squared is 1, their y squared is 9. So see, 1 plus 9 is 10. And 1 times 4 is 4. 4 plus 9 is 13. So all those 4 points, or all those 4 pairs of x, y are your solutions. Basically, this one, x squared plus y squared is 10. Do you remember that was a circle? It should be a circle. It's centered at 0, 0, and with the radius of a square root of 10, right? The radius. Yeah. Barely. Here's root 10. Okay, so what about this one? This one is an ellipse. So that is, I just because I don't have a very good graphing skill, but I can tell you it looks like this. That's a first equation. Did you see that? 1, 2, 3, 4. That's the 4 point. So this is 1, 3, negative 1, 3, negative 1, negative 3, and a positive 1, negative 3. That's your 4 solutions. Okay. So this is very similar to the equation we did earlier, or the system of the linear equation earlier. It's just a little bit more complicated because sometimes you might have to treat like the x squared or y squared as one term and then go ahead and solve it. But basically the method you're using are the same. They are either elimination method or substitution method. Okay, so I think that's all for this class.